Good morning dear students. In your previous video class, you learnt about how to draw a pie chart by using the frequency distribution table. Children, in this class, we will discuss about chance and probability. Chance and probability. Yes, children. Now, let us come to discuss about chance and probability by seeing these examples. Look at children, sometimes it happens that during rainy season, you carry a raincoat every day and it does not rain for many days. One day you forget to take the raincoat and it rains heavily on that day. Everyone knows that a particular train runs in time, but the day you reach well in time, it is late. Sometimes it so happens that a student prepares 4 chapters out of 5 very well for a test, but a major question is asked from the chapter that he left unprepared. And so many students forgotten to the answer in the examination all. These are the situations we come across in our day-to-day life. You face a lot of situations like these where you take a chance and it does not go the way you want it to. These are examples where the chances of certain things happening or not happening are not equal. The chances of the train being in time or being late are not the same. We, however, consider here certain experiments whose results have an equal chance of occurring. Such kind of experiments are called random experiment. Look at the figure, children. Yes. When we toss a coin, there are two possibilities, such as head may come or tail may come. Here, such are called outcomes of an experiment. And see another one picture, that is the winning of a football. In a football match, the result are like this: one is winning, another one is not winning. Such kind of results are known as outcomes of an experiment. Outcomes of an experiment. When we toss a coin, there are two outcomes. There are two outcomes. One is it gives the head, otherwise it does not gives the head. That not does not gives the head means it may comes tail. It may comes tail. Such are called outcomes of an experiment. See now, yes. In this picture, when we throw a die, yes, it gives the 1, 2, 3, 4, 5, 6. There are 6 outcomes possible in that experiment. When a coin is tossed once, there are 2 outcomes are such as head or tail. But the head may comes, that is taken as P. P means probability of getting head is here is equal to 1 by 2. How we can take 1 by 2? Yes, the total outcomes are taken in denominator and favorable outcome is taken in numerator. Outcomes of an experiment are equally likely when each of the followings. Outcomes of an events. What it become outcomes of an event? Each outcomes of an experiment or a collection of outcomes make an event. Listen children. Each outcomes of an experiment or collection of outcomes. So many outcomes are done in an experiment. Such are called, such make event. See, for example, experiment throwing a die. The favorable outcomes. Here event is getting a prime number. Getting a prime number. Favorable outcomes are among 6 number. A die is having 6 number. Among that 2, 3, 5 are prime numbers, the favorable outcomes are 2, 3, 5. Yes, total outcomes of the experiment is 3. Probability of an event is taken like this is equal to number of favorable outcomes by total possible outcomes. Yes, total possible outcomes are 6. Favorable outcomes are 3. So, probability of getting a prime number is equal to 3 by 6. Nothing but 1 by 2. Yes, now let's see other chances of an event. Yes, certain or sure event. Events can be considered as 3 types. Certain or sure event. This event is 100% occurs. Events with 100% chance of occurrence. This event is occurs 100%. Water of the river will evaporate. Yes, children, in the river, water gets evaporated. It is an 100% occurring event. That kind of event is called certain event. Impossible event. Yes, impossible means it does not occur. For example, getting 7 on a die. Yes, children, we know that from 1 to 6 we have to get in a die. When we throw a die, we get 1 from 1 to 6. But 7 is the number, does not occur. Such kind of event is called impossible event. And it is a 0%. Does not, that gives 0%. See children, the third event is may or may not happen event. Take for example the rain. It will rain today. Yes, this is the statement. The statement is possible or may not be possible. Yes, such kind of events are occurrence between 0% and 100%. From the chance to probability, probability is the numerical value of chance of occurrence of an event. Events are of 3 types: impossible event, certain event, and may or may not happen event. As in between the impossible and certain event, there is a may or may not happen event comes. Impossible event takes 0%, certain events take 100%. So we have to give the numerical value like this. For impossible event, it takes 0. For certain event, it takes 1. As in between this may or may not happen event is comes. So the probability may or may not, that is nothing but the probability, chance to probability. As it takes the numerical value from 0 to 1. The probability of any event, it takes the value from 0 to 1. See children, in the example third is a bag has 4 red balls and 2 yellow balls. Yes, the balls are identical in all respect other than color. A ball is drawn from the bag without looking into the bag. What is the probability of getting red ball? Is it more or less than getting a yellow ball? Yes, look at children. A bag contains how many balls? 4 red balls and 2 yellow balls. Totally, there are all are in identical in all respect other than color. Yes, the total balls in the bag are 6. Yes, total outcomes when we take the ball without seeing the bag. Yes, total outcomes are 6 of the event. Getting a red ball is among 6. When we take the ball, is the possible outcomes of we get a red ball is 4. Therefore, the probability of getting a red ball is 4 by 6. Total outcomes are 6. The red ball outcomes are 4. So, the probability of getting a red ball, P of probability of getting a red ball is equal to 4 by 6 is equal to 2 by 3. In same way, the probability of getting a yellow ball is total balls are the total outcomes are 6. the favorable outcome, that means we are getting a yellow ball, is 2. Yes, probability of getting yellow ball is equal to 2 by 6 is equal to 1 by 3. Therefore, the probability of getting a red ball is more than that of getting a yellow ball. Yes, answer is here. Is it more or less than getting a yellow ball? Yes, the getting red ball is more than that of getting a yellow ball. Like this, the total outcomes with the favorable events, both the ratio gives probability of getting a favorable event. Yes, children, now come to exercise 3.3 problems. The first main, list the outcomes you can see in these experiments. Now let us note the outcomes only here. Spinning a wheel. Wheel is going to spin, yes, and tossing 2 coins together. Here, when spinning a wheel, the total outcomes are here how much? 5. Total outcomes of this experiment is 5. Yes, when we tossing a 2 coins together, the total outcomes are, here write, total outcomes are 5. Here total outcomes are, yes, see children, 2 coins are at a time tossed, we get head and head. In first coin gives head, the second coin it also give head. Yes, the possible outcome at a time is head and head. The first coin shows head, the second coin shows tail. Yes, this is second possible event. The third, when we toss a third time, the first coin shows tail, the second coin is also show tail, and the fourth one is, the first one is shows tail, the second one shows head. Yes, possible outcomes are here. The total possible outcomes are 4. Total outcomes are 4, like this. Look at children. In the first experiment, 2 coins are tossed at a time. The first coin shows head, the second coin is also shows head. Second time, first coin shows head, second coin shows tail. Third time, the first coin shows tail, the second coin is also show tail. Yes. Fourth time, the first coin shows tail, the second coin shows head. Yes, the total possible outcomes are like this. Total possible outcomes are 4. Yes. Now come to the second question. When die is thrown, is the outcomes of an experiment of getting. Yes. Outcomes. A die is thrown. Die is having how many numbers? From 1 to 6. The total outcomes are 6. Total outcomes are how much? 6. Here first one is a prime number. From 1 to 6, the prime numbers are 2, 3, 5 are the prime numbers. So total outcomes are 3 for your first one. Total outcomes are 3. Not a prime number. Yes, 2, 3, 5 except 2, 3, 5. Not a prime numbers are 1, 4, 6. Yes, not a prime number outcome is also 3. Next, a number greater than 5. Greater than 5 is only 6. Yes, the outcome is 1. A number not greater than 5. Not greater than 5. Yes, we count include 5. Yes, the possible outcomes are 1, 2, 3, 4, 5. 5 also we have to include for this statement. A number not greater than 5 is total outcomes are 5. Look at children once again. a prime number, the outcomes of a prime number we get when we throw a die is 3 because the prime numbers are 2, 3, 5. Second statement, not a prime number is the total outcomes are here 3 except 2, 3, 5 we get 1, 4, 6 are the outcomes. So the number of outcomes are 3. A number greater than 5 is after the 5, 6 is the only number when we see in the die. So the total outcome is here 1. A number not greater than 5 is we have to include 5 in this statement. So we get total outcomes are 1, 2, 3, 4, 5 is total outcomes are here 5. Like this we have to count the outcomes from the experiment. Children, now come to third question. Find the following. Probability of a pointer stopping on D, question 1a. See children, in question 1a is what is asking here? Probability of the pointer stopping on D. Stopping on D is here the possible outcome of the D is only 1. Is total outcomes are 5. Is how many outcomes are coming here? Total outcomes are 5 and the favorable outcome is only 1. So the probability of getting a D pointer is 1 by 5. 1 by 5. Total outcomes taken in denominator, favorable outcome is taken in numerator. So probability of getting a favorable event is equal to 1 by 5. Is second question. Probability of getting an ace from a well shuffled deck of 52 playing cards is among 52 the ace card are 4. Ace card are 4. So probability of getting ace card among 52 is 52 taken in denominator, 4 is in numerator. This is a probability of getting ace card from the well shuffled deck of 52 playing cards. Yes, third question is probability of getting a red apple. Look at in this figure as the red is marked on 1, 2, 3, 4 apples. Marked on 4 apples. Probability of getting a red ball is P of or red apple. Probability of getting a red apple is equal to is total apples are here 7. Right in the denominator and the red marked apple are here 4. Is probability of getting a red apple is equal to 4 by 7. Yes, now come to children fourth question. What is asking here? Number 1 to 10 are written on 10 separate slips kept in box and mixed well. One slip is chosen from the box without looking into it. What is the probability of is getting a number 6? Second option, getting a number less than 6, getting a number greater than 6, getting a 1-digit number. Yes children, now let us go to answer for this question. Yes, solution for that question is now let us write first numbers. Numbers from 1 to 10. So total outcomes are how much? 10. Getting a number 6. Yes, here the favorable outcome is 6, that is only 1. Is probability of getting a number 6 is equal to favorable outcome by total outcome is equal to 1 by 10. Answer for this question is 1 by 10. See once again children, number from 1 to 10. So total outcomes are 10. Here the favorable outcome, getting a number 6 is a favorable outcome. We get a 6 is only one time. So favorable outcome is only 1. So probability of getting a 6 is equal to 1 by 10. Yes, the second sub question is getting a number less than 6. Yes, total outcomes are 10 and here favorable outcomes are, what is asking here? Less than 6. Yes, we leave this 6. Within 6, how many numbers are coming? Yes, 1, 2, 3, 4, 5. Here less than 6 numbers are 5. So those are taken as favorable outcomes. Favorable outcomes, and the probability of getting a number less than 6. The probability of getting a number less than 6 is equal to, favorable outcome is right in numerator, total outcomes are right in denominator. Yes, it takes 5 by 10. Now 5 ones are 5, 5 twos are 10 is equal to 1 by 2. Yes, this is the probability of getting a number less than 6. Now come to third sub question. Getting a number greater than 6. Greater than 6. Now leave here 6 and count after the 6. 7, 8, 9, 10. Yes, the total outcomes are 10. Favorable outcomes are, count from 7. 7, 8, 9, 10. Favorable outcomes are 4. Is the probability. The probability is represent in terms of P. Is P of number greater than 6 is equal to, is the total outcomes are here 10, number greater than the 6. Here the favorable outcomes are 4. 2 2s are 4, 2 5s are 10. The probability of the number is greater than 6 is 2 by 5. See, now last question, getting one digit number. Yes, total outcomes are 10. Favorable outcomes is, all of you count from 1, only the single digit number. 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 numbers are single digit number. So favorable outcomes are 9. P of getting one digit number, probability of one digit number is equal to 10, here 9. 9 by 10. Yes children, now come to fifth question. If you have a spinning wheel with 3 green sector, 1 blue sector and 1 red sector, what is the probability of getting a green sector and what is the probability of getting a non-blue sector? Children, here the spinning wheel contains 3 green sector, 1 blue sector and 1 red sector. So total number of sectors are is equal to 3 green sector, 1 blue sector and 1 red sector. 3 plus 1 is equal to 5. 3 is red, 1 is blue, another one is which color? 3 is green. Sorry, see, 3 is green, 1 is blue, another one is red. Yes, the total sectors of a wheel is equal to 5. Yes, these are the total outcomes. 5 are the total outcomes. Here first one is what is the probability of getting a green sector? Probability of getting a green sector is equal to, out of 5, green sector is how much? 3. Yes, 3 by 5. And next, what is the probability of getting a non-blue sector? Probability of getting a non-blue. Non-blue, except blue color, the remaining are how much here? 3 is green, 1 is red. 3 plus 1 become 4. Yes, answer is 4 by 5. Yes, children. Now come to the 6th question. What is asking here? Find the probability of the events given in question number 2. Yes, see children, in the question number 2, yes, the events are like this. Events are, when a die is thrown, list the outcomes of an event of getting. One is a prime number. Yes, the first one is prime number. Prime number. Yes, first write the total outcomes. Total outcomes come when a die is thrown. Yes, total outcomes are 6. Yes, among 6, right here 6 numbers. 1, 2, 3, 4, 5, 6. Total outcomes are 6. And here what is asking? Prime number. Among these numbers, the prime numbers are the favorable outcomes. Favorable outcomes are, here prime numbers are 2, 3 and 5. So favorable outcomes are 3. Now probability of getting a prime number. Probability of getting a prime number is equal to 3 by 6. That means 3 ones are 3, 3 twos are 6, 1 by 2. This is the probability of getting a prime number when a die is thrown. Yes. The second question is what here? Not a prime number. Not a prime number. Yes. Not a prime number. Yes, the total outcomes are 6. Write the set 3, 4, 5, 6. Not a prime number. Those are favorable outcomes. Not a prime number means 1, 4, 6. The favorable outcomes are 3. So probability of getting a number, such numbers are not a prime number. Probability of getting a not a prime number is equal to 3 by 6. 3 ones are 3, 3 twos are 6. Is 1 by 2. Yes. Third one is what asking here? A number greater than 5. A number greater than 5. Yes. C. Number greater than 5. Greater than 5. Its total outcomes are 6. Is 1, 2, 3, 4, 5, 6. Is here what is asking? The probability of finding the number greater than 5. Now let us write first favorable outcome. Greater than 5. Which number is greater than 5 here? 6. Only the one number. So favorable outcome is here only 1. Now probability of getting a number greater than 5 is equal to 6 here 1 by 6. 1 by 6. Now come to the last question. The last question is D. A number not greater than 5. Number not greater than 5. D. Number not greater than 5. Yes, total outcomes are 6. Right, 1, 2, 3, 4, 5, 6. Yes, here favorable outcome is number not greater than 5 except 5, greater than 5 except 5. The numbers are 1, 2, 3, 4. 4 are the favorable outcomes here. Now, the probability of a number not greater than 5 is equal to 6 here, 4 here, 4 by 6. Now 2 ones are 2, 2 threes are 6, 2 by 3, 2 by 3. Children, the chapter is completed now. In this chapter, we have been discussed about raw data, frequency distribution table, histogram, bar graph, circle graph or pie chart, and random experiment, probability of an event, and in-text questions. I hope that all of you understood very well. Thank you.